Cool. Hi, everyone. I'm Lucas Pontes, and I'm going to be talking here quickly about the wasmCloud operator. And this is the story for the platform teams and leaving a bit of the development land and going to operations a bit. So up until now, we've been talking a lot about WASH in terms of components and capability providers development. And the usual flow is once you have your component built, once you have your provider built, you're going to push that code up to Git. That's going to go through a CI pipeline and generate an OCI image of your component or provider. From this point on, another group in your organization, the platform team, will get that code and is responsible for getting that code and putting that in production in your public cloud, bare metal, anywhere. And this group is more familiar with like a different set of tools. And the wasmCloud operator is tailored to help the life of those folks. They are dealing with kubectl, they're dealing with Jenkins, they're dealing with a different set of systems that developers might not be exposed all the time. What the wasmCloud operator does is it facilitates the setup of a lot of the infrastructure and applications, helping the lives of operators and again, making sure that wasmCloud is adhering to the industry standards that most companies are familiar with. So what does it do? It allows us to create groups of wasmCloud hosts and also deploy application manifests. I'll show you in a bit here how these look like. But for right now, just think that these is pretty much YAML that we're talking about. The other thing that the operator does is as you expose capability providers in terms of TCP ports from wasmCloud, those need to be reflected in Kubernetes so they can be exposed using load balancers, ingress interfaces, and other things. The wasmCloud operator is watching your deployments in wasmCloud and making sure that these are also being exposed on the Kubernetes side. And the third thing is integration to Kubernetes secrets. This is a good one because you need secrets at some point in your application. You don't want to be putting your secrets in a YAML file, putting that in Git, and calling it a day. The interesting thing with the secrets integration here is because we're integrating to Kubernetes secrets, you can bring in an external operator like the external secrets operator and plug into many different endpoints. AWS Secrets Manager, Google, Vault, you name it. And the repository for the operator is under wasmCloud operator. And host groups. Host groups are pretty much the wasmCloud runtime itself. When you run wasmCloud, when you run wash up in your laptop, you're bringing up a single wasmCloud host. What the CRD here is doing is you tell it which version, which lattice, and how many you want. And it will take care of creating the deployment and also enforcing some good patterns in standing up wasmCloud hosts. So every time you bring up one wasmCloud host, we make sure there's a companion NATS leaf node right beside it, so it can have faster communication with NATS. It's also responsible for making sure that the configuration traverses from your YAMLs down to Kubernetes deployments into the actual pod, and also the communication on the other direction. Is this pod healthy? How many applications do I have deployed in each host? Do I need to recycle them? How do I upgrade them? So the status reporting here is also an important part. The other thing that is interesting is because now you have this being declarative, and you can use any tools that you already have in your DevOps arsenal. If you have Argo, if you have Flux, if you have kubeconform to check if your YAML is in check, these things are all possible. And as Bailey previously mentioned, WADAM is our application orchestrator. And the manifest there looks suspiciously like Kubernetes. And this is not by mistake. What we're doing there is we're using a spec called Open Application Model, which is rooted in Kubernetes, making this a very good match that you can, in your local development, use wash app deploy to deploy an application to your local wasmCloud environment. And the operators can use kubectl apply on the exact same file and get this to work once the operator is there. In this manifest here is where you're going to declare your components, your providers, your links. Everything that you want on your application goes inside this file. The other thing that the operator is doing is the service reflection that I mentioned initially. And this is done in a way that we keep the life cycle of the service being exposed in sync with what is happening inside wasmCloud host. What this means is we set up a finalizer on those services to make sure that they don't simply go away by themselves. So if they get deleted, the wasmCloud operator gets a chance to go in there and maybe recreate it, maybe update it, you name it. The lifecycle here is also important because if you bring up more wasmCloud hosts to your system and you start positioning, you start spreading providers that existed into these new hosts, the operator will also include these new hosts into your service, into your endpoint slice. And the other bit is about the secrets integration that I mentioned initially. The important thing here when bringing secrets to Kubernetes, wasmCloud secrets to Kubernetes, is we need to make sure that we are playing nice in the Kubernetes ecosystem. We need to respect service accounts. We need to respect RBAC, namespaces. And this is done through the concept of policies. In here, we want a wasmCloud secret called API key, and we want to fetch it from the Kubernetes default policy defined up there. We want to get the secret called app secrets, and inside that secret, we want to get the secret key API key. So you can imagine that this might live in the same namespace or in a different one, and you can configure those things here through the policy just by adding service account or default namespace in the property section. And now I'm going to do a kind of a quick demo here, which is going to show a bit of the senior YAML engineer chops. What I have is, all right, quick start, nice. What I have here is a Kubernetes cluster, which already has the operator installed. And I want to bring up a wasmCloud host and also deploy one application. Let's see how many pods we have going on. So we just have Nats, WADAM, and an Alpine container that I was playing initially. In terms of YAMLs, we have a wasmCloud host config YAML, and this is going to bring up one wasmCloud host in the 104 version in the lattice default. And you notice that I didn't specify the number of hosts. If you don't specify the number of hosts, the default is 1, kind of to show that we also have some same defaults underneath the system. Getting the host there. Once we apply this, we're already creating a deployment and a pod for wasmCloud host. And from this point on, we can describe that and see all the properties of that specific wasmCloud host. We don't have any applications deployed there. It's connected to NATS, the version, and everything. For my application, what I have here is a basic Hello World application, which is coming with one Hello World component and one HTTP provider that's going to be binding it to port 8080. And once again, I can do this with kubectl apply. Now, the interesting thing here is I can do the kubectl approach, to show that this application is deployed, or I can use wash still. So these things are working in sync. When we request information from Kubernetes, what is actually happening is Kubernetes is going over to wasmCloud host, asking how many applications are there, and coming back. This is to say that we implemented the operator here as an API service. This means that doesn't matter if you apply your applications using Wash and check them via kubectl or vice versa, the system will be consistent. There is no way for somebody to install an application using Wash that the operators will not be aware of. And once we apply this application here, we also see that now we have a hello world service here on port 8080. Again, this is that service reflection that I was talking about a few minutes ago. This is all great. And where can I see this that you just showed? There is a quick start, which is literally this thing that I went through here. It shows you how to install the operator, get nats with them, and also the bringing up a wasmCloud host and a sample application right beside it. In terms of future work, we know that the installation story right now is not the best. This is because you have to install nats with them, the operator, and they each one have their own installation procedures. So there is some Helm installing that goes in there that requires a bit more love. We have a member of the community working on a Helm chart that will encompass that and make sure and make it so the Kubernetes story comes in a single Helm chart in a way that things are way easier to install. We also want to look into the gateway API integration so we can plug wasmCloud easily into Envoy, into Nginx, and other Ingress classes. The other part that it's coming up soon is the ability to create end-to-end clusters. You might want to create multiple wasmCloud clusters inside a single Kubernetes cluster, or you might want to create one wasmCloud cluster that spans multiple Kubernetes clusters. So these things are important in the day-to-day for any company at this point, and we want to make sure that we are supporting those use cases as well. And that's the end of the operator chat. Once again, thank you.
Hey, Lucas, me again with another question.
Hi, Brooks.
Yeah, hey. I had a question. So I think I understand the wasmCloud operator, but I think that the separation or the distinction of like where should I run and like should I run an application in wasmCloud? Should I run the application on Kubernetes like with who I am today, with like the way that I'm doing it today? And I think a lot of people would be surprised to see that we're deploying wasmCloud on Kubernetes. Can you talk a little bit about like what the benefit is here for an operator like us running WebAssembly with the wasmCloud orchestrator and then like deploying our platform with a different orchestrator?
Sure thing. wasmCloud itself is in the pillar of infrastructure. You can see it as a separate layer. So you have right close to the metal, the actual hardware, you have the operating system, you have containers, and right up until components came around, we were allowing all developers to have the same level of access that like an operator root security teams would have. The fact that we're deploying wasmCloud on top of Kubernetes means that we now have another layer, and this layer is responsible for components. So in this layer, operators have way more fine-grained control over what they are allowing the containers to do. So where previously you allow somebody to deploy a container and they can shell out, they can open TCP connections, they can poke around in the cluster. With components, it's a deny by default, and you allow them to do specific things. The importance in the key point here is we are wasmCloud is Kubernetes for components for WASM, but it can also run in isolation somewhere else. We can take wasmCloud, run that in bare metal. We can run that in satellites. And you can imagine a situation where you have your Kubernetes cluster in US East 1, like many people do. And you also have your data center with just 3, 4 servers. And you want to see that communication happening as a single flat network. So you can target, you can deploy a component and say, I want this component to be running only on my data center, or I want this component to be running only on my Kubernetes cluster. And this, I think, the interesting concept here of seeing wasmCloud more as a layer on top of your existing infrastructure.
It makes sense. Really cool.
Awesome. Thanks, and I'll hand it off to you, Brooks.